Alright, so let's make that paperless towel dispensing program. If you overwrote your template, no worries. Just have to go to File, Open Sample, pick the PLTW again, and pick the one called Backup. When it opens, right away, go to File, pick Save As, and rename it. I call mine Paper Towel. Alright. Fill out your project title, team members, the date, and the section. Fill out your task description and the pseudocode portion. I'll just do mine verbally, save some time. But basically, we want to have our paper towel dispenser motor. So you've already built your that same base you used for the mechanical gears lab, and you've got the gears on there and the motor on there with the idler gear set up. And I want to use that to have the paper towel dispenser be motion sensor activated and have to be a reset with something of a button press. It's a bunch of new things we're going to learn here about this program, and I'll kind of help you along because it's new and we're all new. But first I have to go up to motion or motor and sensor setups. My motors, I'm going to have a motor. I'll call my motor 1. It's going to be a VEX 393 motor. I want some sensors, analog sensors and digital sensors. Digital, as you know, is either a 1 or a 0. It's an on or an off. So the button press would be a digital sensor. I'm going to call mine here tap, because I'm going to tap the sensor. When you pull the paper towel off the machine, it taps the sensor. I'll call my tap. And it's going to be called a touch. And then my analog, this has a variable range of data from 0 to 4,000. This is my motion sensor. So I'm going to call mine this MS for motion sensor. And what it is a line follower, because they look on the side of the little doodad. It says on the side of it, it's a line tracker, but it's called a line follower. And I'm going to apply all those three and say OK. So here we are. I have three things. Sensor, it's in my analog port 1, sensor and digital port 1, and then my motor in port 1. So on your VEX Cortex, you plug your light sensor, motion sensor 1, the line tracker in the analog port 1. You plug your limit switch or your tap switch in the digital port 1. And of course, plug your motor in the motor port 1. Here's what's going to happen. Is I want my program to run continually. So over and over and over, not just a one and done deal. So I have to give it a condition that's going to always be true, so it'll always run itself. And to do that, we're using a code called while. So while a certain condition is true, it's going to repeat the program over and over again. Or for our sake, the ones that bathrooms have, it's while the battery is charged, it'll run. When the battery is dead, it stops. So type in while, it should turn blue. Let's go parentheses. I'm going to go 1 equals 1. Because 1 always equals 1. 1's always true. End parenthesis. Hit return. Well, now I have to put brackets. Because notice up here is a bracket that begins and a bracket to end. Well, I want to have this run the next set of codes. So I'll put a bracket. Nope. Bracket. Hit a return. And now I have things going inside of a bracket. So again, just take your time. Pause when you need to. Rewind if you have to, and watch along. So I'm going to have my motion sensor be my trigger. As long as there's no hand in front of it, it won't run. When the hand's in front of it, it'll trigger to run. And that's going to be a sensor under until. So until someone's hand gets pushed in front of it, it's not going to run. And I want the one called until light. It sounds backwards, but it's the one we need. So until light. And threshold means, well, how much light is going to be let in for it to trigger itself. In this case, I'll show you the number. I'll show you how I found the number. I want 2000. And my sensor port, that's the one that my motion sensors, I call mine MS. So it's until a hand's in front of it, that'll trigger. I want that to start my motor, so I'm going to type in start. There it is. Double click it. And my motor, I call my motor 1. And I'm going to go slow for now, I'll call mine just 20. And I must see up here, that little semicolon, that's needed to show an end of a period. It's the end of a sentence. Start my motor. I'm going to have it wait maybe 3 seconds. Semicolon. I'm going to go stop motor. Oh, can't see it. Where's it at? Come on down here a little bit, Mr. Oh, don't cooperate, this crazy computer. Stop motor. There it is. My motor is called 1. So now if I run the program now, it only run once and it would end. I want to be able to run continually, so I have to have that when the paper towel gets torn out, to reset itself to keep running again. And that's done by doing another sense called until bump. So when that paper towel bumps against that sensor, it'll trigger that little thing to make it cooperate. In this case, I'm using that one tap switch, so mine's called tap. And I want to have no delays, so I'm going to take this off. It's until tap. And then I have to close that. It's got one that begins it and one to end it. This begins my whole program. End down here. This begins my while statement, ends down here. So I'm going to compile my program. I'm going to save it as paper towel to my desktop. Okay, good, no errors. I'm going to go download to robot. Okay. Now let's give it a test. If I push start, it's waiting for that motion sense to happen. So it's saying I want to go here, but I can't because it's still no one's hands are on the motion sensor. So if I take my hand and put it for the motion sensor, it ran it. Now it's waiting and waiting. Touch it again, the sensor, nothing, nothing. Once the paper towel gets torn from the machine, hit my bump switch. See that there? It's waiting again. Sense it. There it is. So that's kind of how that works. How I found that lights things, I'll show you that when I get back to school. But now your next challenge is, well, what if I wanted to maybe on my next time have a next bump switch to run it faster? So what if I added some more programming to this and say, well, here it goes until light, turn the motor on, wait, turn the motor off, now it's waiting. I could here again too put until light below this, and then of course I could have it run without this bump switch. That's kind of the fun part, and the bump switch activated. So I think your challenge to you then is to make this your better. Is maybe you want to have the next time I do a bump switch, maybe have it advance down into maybe a faster motor run. What if I had here, let me stop the program. Now the bump will go to the next one, maybe start the motor again. Start the motor. This time I'll call it same motor 1, but I want to go to maybe a negative 120, have it go reverse. And has to, of course, wait for, let's go 1 second, make it fast. And then we'll stop the motor. And that's also going to be 1. And I'm going to have it somehow triggered to go back up the top of the hill again as my untail bump. And I'm going to go tap. Now let's compile it. Uh-oh. Oh, here it is. See, my semicolon's not there. Semicolon, 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 semicolon. Now compile it. There we go. Download robot. And let's run this. Okay. So I motion sense the switch. It runs it. I bump my bump switch. Whoa. Bump it again. Resets. Motion sensor. Aha. So my challenge to you is make this year program better. Make me be an evil paper towel dispenser. Good luck.